Review on oblique asymptote. Consider the function f of x equals to ax squared plus bx minus 3 divided by x minus 4. Determine the value of a and b so that f of x has an oblique asymptote of y equals to 3x plus 1. Interesting. Now if you recall, what is the condition for a function to have an oblique asymptote? Well, a rational function will have oblique asymptote if and only if numerator degree is 1 higher than the denominator. In this particular case, the degree of numerator is 2 and that of denominator is 1. So when you divide numerator by denominator, you get a linear function as a quotient, and that linear function is actually the oblique asymptote, right? So I think that should help you to figure out what is the value of a and b from the given oblique asymptote. Try to recall, okay? You did it long time back while working with functions, and especially rational functions. So what I'll do is I'll start my solution. Think about it. Why am I doing that? So what I'll do, I'll multiply x minus 4 by 3x plus 1. What do I get? So I get x minus 4 times 3x plus 1. Now x times 3x is 3x squared, and then plus x. Minus 4 times 3 is minus 12x, and minus 4. I can combine these terms and write this as 3x squared minus 11x minus 4. That is what I get when I multiply these two, right? Now how do I find a and b from here? Well, as we said earlier, when we divide numerator by denominator, the quotient should be 3x plus 1. That is what will help us to get the answer, right? So let's do that division. So let's divide. So when we divide, the number here is ax squared plus bx minus 3 by x minus 4. We should get quotient as 3x plus 1. We should get here 3x plus 1. And now we know x minus 4 times 3x plus 1 is all this. That is 3x squared minus 11x minus 4. That is it. Now from here you can find the value of a and b, correct? What should be the value of a and b, right? Can you tell me now? So a should be 3, right? Only then you get 0 here. We need to get 0 here, correct? And we need to get plus 0 here also, right? These are the numbers, and we can get any number here. And if we do minus 3 minus 4, then minus of minus 4, we get plus 1 here. Now from here you can figure out what a and b is, correct? To get this 0 here, a should be 3 and b should be minus 11, right? So we get a equals to plus 3 and b equals to minus 11. Do you see that? And therefore our function f of x actually can be written as, we can write f of x as equal to 3x plus 1, and the remainder is 1, so plus 1 is the remainder, over x minus 4. Do you see that? And that becomes our oblique asymptote. Do you see that part? So this is the oblique asymptote, and that's the remainder. Since the remainder is positive, the function will be over, slightly over 3x plus 1 when you sketch this function, right? Now we have fairly good understanding now of oblique asymptote, and we'll go ahead and sketch some rational functions where you'll find oblique asymptote. Thank you and all the best.